So, hello everyone, I'm Tim from Tim's PC and I build custom PCs to suit anyone's needs or budget. I also live stream my builds and repairs for transparency and educational purposes. So if you'd like to get an awesome new PC and you'd like to see it get put together live, send me a message today. So this is basically the star of the show. I say that tentatively because we are building a gaming PC and the fundamental gaming performance is dictated by this bad boy right here. But this 9800X3D chip is like the next generation gaming CPU. It's kind of all ready to go, ready to pair with the new Ryzen 5, Ryzen I should say, the NVIDIA 50 series cards that are coming in soon. And like I was saying before, this is what's causing them to sell out. So our motherboard here, we've got an MSI Mag B650 Tomahawk Wi-Fi. It's quite a nice motherboard for the price. We'll have a look at that when we unbox it. We have a kit of RAM here. This is 6000 megahertz CL30. So just remember, 6000 megahertz CL30 is pretty much the sweet spot between performance and latency and the actual clock speed of the RAM. So just like with DDR4, it was the 3600 megahertz CL16 RAM that was like the sweet spot for like performance and all that. Like if you went up in clock speed from then, the latency causes the performance to drop. So above that 3600 CL16, you're going to start losing performance. You may as well have just got 3200 megahertz CL16 memory. So this stuff here, so 6000 megahertz CL30, that's pretty much where you want to be at for DDR5 right now. That could change in the future as different kits come out and all that, different motherboards, and you know, who knows, that could change. But at least for the time being, that is the spec that you want to aim for if your budget allows for it. So we got a Silicon Power US 75 NVMe SSD. It's a 2 terabyte one. This is Silicon Power's top performing SSD. So this is basically like your Samsung 980 Pro or your Crucial T500 SSD. So this is actually, you know, Silicon Power have some sort of budget SSDs, but this one here is definitely not a budget SSD. This is actually this is their top performing consumer SSD. Alright, so our graphics card, we got a PNY XLR8 RTX 4080 Super 16 gigabyte. I'm going to put that one down here into the side for now because it's the last thing that we use. We have a Thermaltake 850 watt ATX3 power supply. This is the Thermaltake GFA3 power supply. So this is one of their top tier power supplies with a 10-year warranty on it. 80 plus gold efficiency. But remember that efficiency rating, that's not your guide to quality, it's your guide to efficiency. The quality of it's dictated by the fact that the manufacturer will give you a replacement for a failed unit within 10 years. You know, you can't really make electrical stuff better than that. You know, even I don't think you're going to see that 10-year warranty get exceeded, you know, anytime within the next 50 years. So hopefully I don't have to eat my words, but we're kind of at a point where the tech's pretty good and it's hard to make it get too much better than where we're at. It's like car engines right now. We've got them to the internal combustion engines to a point now where there's not really too much more room for more power and efficiencies like pulled out of that system. So our cooler here, we have the MSI Mag coreliquid, what they call is the A13 360. It's basically their revision of the Mag coreliquid. This is another one that's probably made by Acertech or Cooler Master under license. It has a pump in the block. It's not guilty of the same problems that some of the earlier MSI coolers had that you may have heard about. So, and then finally our case here is an Antec P20C case. So this is actually the same case that I have for my personal rig right now, only I have some Thermaltake toughpower RGB fans. The one with the blades are black, but everything else on the fan lights up. They're just fucking weird. There was something different, and I thought I'd get one to show them off to people, because I thought they looked pretty cool. But I was a bit like, I'm not sure if people are really going to go for that design. At the same time, it might be sort of a more niche thing, and I was right. So, alright, let's get stuck right into it. So, let's move over to our board view now, because we are going to be unboxing this motherboard. Integrated I/O shield there. We get our Wi-Fi antenna, our SATA cables, some M2 screws there. Little bits and pieces. European Union regulations. Not sure how much of that applies here. Quick installation guide, very important. And notice that the board has a battery in it, so don't eat the battery. And we get some nice little MSI stickers there as well. It's a nice touch, isn't it? Okay. Okay, so let's have a look at this board. So you can see it on the screen there, a lot bigger and a lot clearer than me trying to hold it in front of the camera there. So I'll go around the board here, and we'll start from the top corner up here, where we've got two 8 pins of CPU power there. So not sure why you'd want to draw up to 500 watts through your poor little CPU, but it's nice to have, I guess. We have these good direct touch heat sinks here on our MOSFET VRM co-processors. These are quite decent solid heat sinks here, like they're not half-ass or anything like that. But obviously we've got our AM5 socket there in the middle. We have 1, 2, 3, 4, 5, 6, 7, 8 fan headers. So a full 8 fan headers on this board. That's the maximum that a motherboard can support. We've got 1, 2, 3, 4 RGB headers. We've got obviously dual channel memory there across the 4 slots. We have our 24 pin ATX power there on the side. We have a total of 6 SATA ports, so 4 horizontally orientated over there and 2 vertically orientated at the bottom. We have a single USB 3 that is horizontally orientated there. We've got a speaker header, 2 USB 2s. We've got some other headers down the bottom there, like a COM port header, debug header. That's one of the RGB headers. We got our front panel audio header there, and this group of yellow capacitors here. These are our audio capacitors with the insulation around them. So obviously audio is an electrical signal, and it's subject to EM radiation interference from other things on the board, so it's important those capacitors are insulated. We have a total of 1, 2, 3 M2 slots on this motherboard, and we've got our PCIe X16. We have an X4 slot there in the middle, so it's only connected that far across, right where my finger is. And this little one here is just a little X1 at the bottom. And then around the back here, got our rear I/O. So we've got a display port and HDMI. You don't really want to use those ports because then you'd use the onboard graphics on the Ryzen 7 there. You want to be using your graphics card, whereas it's behind me there. And a solid amount of USB ports there. So that's a total of 10 USB on the back there, including a Type-C there, 2.5 gigabit LAN, Wi-Fi 6E and Bluetooth 5.2, SPIDIF out, and audio there at the bottom. So a really good board, really good rear I/O, really good features, but not super expensive. It's not an $800 motherboard or something like that. So definitely something to consider. You know, you're just a normal person. You don't need to spend ridiculous amounts on the motherboard. It's as you get higher and higher in motherboard spec, a lot of it is for enthusiasts who really like motherboards, particularly. Not because like the motherboard's giving them that much more performance, they just like the look of it, so they'll spend a lot of money on the board. Or they're overclocking and stuff like that, so they need the absolute top spec of the motherboard to be the most compatible with overclocking. So, alright, so we'll chuck our SSD in here, and because we got a pretty decent SSD, I'm going to install it in the slot here with a heatsink. Now that top slot there is PCIe 5, so if you wanted to use a next gen SSD up there, you can. The problem is with PCIe 5 SSDs is the speed is a bit redundant because the software has various bottlenecks in it that sort of stop you getting the benefit from your SSD beyond a certain point. So yeah, we're sort of waiting for other things to catch up in order to benefit more from performance gains with our SSDs right now. So I mean, that just is what it is. You get that with everything. Certain tech expands too much, and then before you know it, it's a case of there's not much point expanding any further on this particular tech because now we're held back by this. You know, it's like, you know, in the 90s there was no pressure to start like filming everything in 16:9 and, you know, fucking making sure things were ready for 1080p and stuff like that. You know, we're in a different freaking era, and even if you did make the TVs compatible with that sort of shit, it's not going to matter until the fucking TV stations stop broadcasting in freaking 4:3 format. You're not going to get the benefit from your new TV. You can buy it, but you're going to get those black bars on both sides of the screen when you're trying to watch TV or a movie or whatever. You know what I'm talking about if you're as old as me. Alright, so we've got our RAM installed, we've got our SSD, now we've got our CPU. Like I said, this is like the star of the show here, the Ryzen 9 9800X 3D. Now if you've got a 7700X 3D, don't flip your shit here or anything like that. This isn't game-changing performance compared to 7800X 3D. It's just game-changing performance based on other non-X3D chips, basically. And so now we're on to LGA style sockets here for our CPUs. Sorry, I have another CPU there that really needs a container. So it's really important you don't damage the pins inside that socket. Okay, cooler time. So our cooler and our motherboard there match. I could have got a matching graphics card, but it was going to cost $100 more, and it doesn't need it. It's not like it's going to make any big difference or anything like that. And honestly, the card that I've got now has got some addressable RGB lighting in it and stuff. It's cool. It's objectively the cooler graphics card, and it's, you know, $100 cheaper. So, and yeah, don't worry. You don't have to worry about PNY if you're seeing it and going, "Oh, PNY, I don't know about that." Blah 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 blah. Their quality of graphics cards and stuff's been great. And what do I base that on? I base that on the number of returns that people have, not just me, but other people in the industry. Because I don't do what I do in a vacuum. I have friends around the country that do the same kind of shit that I do in terms of building PCs and stuff. Oh, look at this. This revision model cooler has pre-installed fans. Look at that. And they're daisy chained fans. Bloody hell. All right. Okay, so we've got our AMD feet there. We're at some screws. We have an LGA, sorry, not LGA, I should say an Intel backplate there. Don't really need that. Okay. Well, that's nice and easy, isn't it? Sorry, I just misplaced my screwdriver. So this cooler here utilizes the same backplate. So I'm just swapping the feet over here on our pump block. Oh. Okay. It's a little bit awkward because it had the Intel feet pre-applied, so I've got to like take it apart and then put it back together. Okay, that's looking good. No, it's one direction. Is it? Really? Okay, alright. Well, that's kind of a bit weird. Alright, it's got to go this way then. Make sure you remove this and apply your thermal compound. That is absolute plenty. Okay, so that's all sorted, so we can turn our attention now to the case. I'll say a quick hello to anyone here in the comments, anyone I haven't been keeping up with. Rick asks, hi Tim, do you need to update BIOS on the board prior to using a 9800 X3D CPU? 100%, man. If you're not buying a board that's, you know, sort of brand new and stuff, you will most probably have to update BIOS before you use a 9800 X3D CPU. So it should say on the box if it comes pre-ready for that CPU. So what we got here on this board? This board says it's 8000 series ready. 8000, 9000. It'll post, I'm pretty sure, in my experience. But yeah, if you're updating for yourself, right? You're doing it at home and you bought a AM5 platform and you've had it for more than like 12 months or so, definitely update your BIOS before you install your new chip, because if not, you'll probably have to go back to your old chip and update your BIOS and then put it back in. So it's always easier just to go and update it then and there, right? If anyone was watching the other night with the PC with where the Wi-Fi wasn't working, when I went and tracked down that frickin' Realtek driver, it worked. After all that. Average person's not going to even know to go and look for a company called Realtek and look for the model of the Wi-Fi module and then find it. You know, people go, well, it's from the board, right? So I'm going to go, if my board's MSI, I'll go to MSI, and if they don't have the driver, then fucking I don't know what to do. Okay, so nothing else to prep. The offsets are in the correct position at the back there, so how much room we got at the top there? We might do the power supply. Alright. So evidence that you might be getting something, you know, premium in terms of your power supply. Does it come with a nice material sheath on it? Oh, yours doesn't. Maybe your 80 plus gold power supply isn't quite the same as my 80 plus gold power supply. Alright, so what's cool about this? It's ATX3 compliant, so it's got a 12 plus 4 pin for our graphics card directly from the power supply. We don't have to use any skanky adapter cables, and it's a top quality unit. Okay. Alrighty, so here's our motherboard cable, 24 pins on one end, 20 plus 10 pins on the power supply end. So you have to plug in both of them. I know it sounds really intuitive and stuff like that, but I've had people bring me computers with their power supply and they've only plugged in the 20 pin to the power supply, not the other 10 pin, and it's like you really need to plug in all of the cables. But anyway, okay, so there's our 12 plus 4 pin there. So that bad boy delivers 450 watts. You don't use more than that unless you overclock them, basically. Okay, so I'm going to fill up this pouch here with goodies. Things like a little bit of thermal paste there if you need to redo your CPU. Oh, look at this. Little bag of spare bolts. How cool is that? if you ever want to swap to Intel, we got your cool stickers there. We got your Wi-Fi antenna, your SATA cable, and your AM5 socket cover. Very, very important. I'm not being a dick there. It is important because if you send your board back to me for whatever reason, you need to have that thing onto it to protect the pins. Okay. No, I don't need them. So just make sure when you plug cables into your power supply, make sure that they're fully plugged in and plugged in all the way. I know it seems kind of obvious, but it's one of these stupid freaking power supply shroud things. For some reason it's meant to be easier or something. So always make sure your fan's turned down, because you don't want to be drawing air from within the case. Power supplies overheat at lower temperatures than everything else in your case, so you want to be drawing cool air from outside your case directly onto your power supply. Okay. Well, while I remember, let's go back to main view there. Because my lovely wife works nights at Coles, so it can be a little bit dicey sometimes doing the live streams on my own. Alright, well, we need another fan on the back. Have I got something I can chuck in for free? Alrighty, here we go. Here's a sparey. Okay, so So we need to make this cable here look like it's just a single cable. Yeah, sweet. Okay, we're getting there. once I get all this in place, Alright, so the ideal position, we can get 10 out of 12 of the top bolts in. As long as you get at least 50% in, it's fine. Okay. Alright, so at the back here, it's actually pretty straightforward, believe it or not. I know it looks like a bit of a clusterfuck right now, but it's really not that bad. Man, I sounded like Elon Musk then, talking about the Hyperloop to some fucking young bitch. I swear it's not that hard. I don't know, Barry. What do you think of Elon Musk? Do you think he's a flop, or do you think he's like the frickin' savior of humanity or some shit? Okay, so everything on the controller there is DC fans. The radiator has PWM fans. So what that means is there's two different fan modes, which is pretty common for different fans within our case. And so this stuff here, these are like the little finer points that people don't usually understand when they build PCs, like when amateurs build PCs. And I don't mean that in a derogatory way. I live on acreage. I gotta, like, you know, cut down trees and fucking move dirt around and fix fences and shit. But I'm an amateur. I'm no fucking pro chainsaw motherfucker or fucking fencer or anything like that. I'm very much an amateur. And that's fine. I know I'm an amateur. There's nothing wrong with being an amateur. Okay, so that header that I just plugged into there goes from this controller here. So these are all, like I said, these are all DC fans. So that particular header needs to be changed to DC addressable. So these fans power up and down as what they need to, and that they, you know, are working as DC fans. They power slightly differently. PWM fans allow you to make the fans spin slower, not faster. It's not like one has more power. The fans can only handle a certain amount of power. There's not really a great deal of flex room there. Okay, so what we'll do is we'll plug this in, plug the radiator into the system fan 1 header. That's all fine. Now that our radiator's on, we can get this back fan in place completely. Okay. So we can just hook these up all on the same header. However, because we've got two RGB headers, I'm going to hook the block and the radiator up to one. And I'll hook the rest of the fans up to the other one. There's our USB-C. Okay, we're nearly there, I swear. Just a couple more screws on our motherboard. Okay. So that is everything other than our graphics card. Alright, so the star of the show here, or the other star of the show, alright, we've got a massive triple slotter here. We have a built-in graphics card support. Okay, look at that. That's in. And then finally, that glass there is from the damaged PC. I'm like, why the fuck does it not fit? Okay. Alright, so while that's waiting, let's go and run our benchmarks here. So we start with Heaven, High, no anti-aliasing. So I'm going to restart without performing updates, and we're just going to go and configure our fans in BIOS, because like I was saying before, we have a mixture of different fans. Some are PWM and some are DC, and our pump is connected to the CPU fan header itself. So alright, so on an MSI up motherboard, we go over here and we go to hardware monitor. Okay, and so we got our CPU there. That, why is it not showing an RPM? But that's fine. DC, just turn off smart fan mode. That means it just runs at full speed. System 1 here, so system 1 is PWM and we want smart fan mode, so let's quieten her down. And system 4 over here, this is DC, but we'll activate our smart fan curve there for it. Get these bad boys running a bit quieter. Alright, that should be, yep, cool, cool. We can chuck on our XMP there. There we go. So yeah, make sure you key in your different fans, because if the voltage isn't set up correctly in BIOS, they won't perform properly. Some of them will just sit at full speed the whole time. You want your fans to be addressable and to go up and down in RPM properly, and in order for that fan curve to work, it needs to be on the right mode for those fans that you have connected to it. So a pump from your radiator, that will typically be a DC connection there. Not typically, it always is a DC connection. So that's the 3-pin fan header. So you want to plug that into your CPU, then just let it run at full speed the whole time. That's what a pump's designed to do. Just let it do its thing. Making it go up and down in RPM is actually bad for it, so don't do that. And then yeah, for your other fans, if it's a 3-pin cable coming from the fan, then that's a DC fan. If it's 4 pins, it's PWM. So, you know, it's not rocket science or anything like that. It's just one of those things that you need to be aware of. If not, you might have, if you have DC fans that are on PWM mode, they sound like they'll just be on full speed all the time, and the addressability doesn't work and all that. So if you got problems with your fans and you can't talk to them properly, you may have an issue where you just have to go in and adjust the type of fans that's connected. Some motherboards have an auto detect feature that sometimes works, sometimes doesn't, so just be aware. Okay, so stress test time. We'll do the last restart there. I just need to get Cinebench working. Oh, MSI Center didn't install. Need MSI Center. Did it install the Wi-Fi driver for us? Yep. Cool. I can't remember where this is being shipped to. That's weird. There it goes. Okay, so that's Brisbane there. Very good. Hardware monitor. Okay, so got our graphics card there, we'll log our temperatures there. So GPU, that can get up to 83 degrees. Memory and hotspot up to 100. We've got our CPU. Where's our CPU? Here's our CPU. So where's our temperature? Oh, yep, here we go. Our temperature there can get up to 95 degrees on an AMD. So when we stress with Cinebench, it will go right up there. That's what it's designed to do. Because this chip's optimized for gaming, it's not optimized for productivity, and Cinebench is more of a productivity benchmark because it's a multi-core, multi-thread workload. So an X3D CPU in the wild won't run as hot as what it does in the stress test, and that's fine because this stress test is designed to get this bad boy nice and warm, simulating what it's going to be used like when you're gaming for hours straight on it. You know, some people call me, they start freaking out, they touch their case, they're like, the case is like kind of hot. Is this a problem? And it's like, yeah, your metal case absorbs heat and dissipates it. The fact that it's warm just means that you've got power running through your system, and it's moving to the metal and it's dissipating into the environment. So it's normal for your PC to be warm. It shouldn't burn you when you touch it. So if you touch it and it feels like, you know, burn like 60 degrees on the top of it, you might have a bit of a problem there. Just saying. Might be something you can change just by optimizing your fans and stuff like that, but yeah, it can get warm. You can expect it to get into the 40s, 50s under load, so your PC case will get warm, the glass will get, you know, nice and toasty sitting next to the graphics card there. But yeah, like I said, that's completely normal. So what we do here is we go for the biggest resolution we can, because the capture card that we're running this through is 1080p. We could plug it in with a DisplayPort cable directly, and we could do 4K or whatever. But this is fine for all intents and purposes. There's our big furry donut. And over here, set this one up for a 90-minute run. Brilliant. So yeah, all of a sudden it's jumping right up there. And our graphics card. Our graphics card is just going to purr. Like I said, we could run a proper full-on burn of our graphics card there, doing fucking 4K rendering. Okay, so there's our CPU there pegged at 100, and our graphics card there pegged at 100. So that's what the stress test is. So we let this one run for 90 minutes just to, like I said, run a bit of heat through it, get it all heated up, and then hopefully if something's going to die, it's going to die while we're doing the stress test and not once we ship it off to the customer, because that's the whole point of doing the stress test. Okay. Oh, I can't quite read the name there. Sorry, man. He says, I've got to say the built-in GPU on modern CPUs is so useful for troubleshooting in certain cases. Yeah, absolutely. I mean, it's not even anything new. Like fucking a lot of systems use just an integrated CPU graphics, like an integrated GPU or an iGPU on the CPU. So the thing about like the modern Ryzen GPUs, like from the 5600G up, is if you set them up right. My most popular videos on YouTube is how to set up like the 5600G and other AMD CPUs to run and run games without actually having a graphics card installed in your PC, and it does really well. Let me just find you guys a link. Oh shit, hang on, I don't have a keyboard for the streaming PC. So while I don't like to promote other YouTube channels, check that out. It's pretty decent for what it is. But you do need to go in and allocate at least 4 GB of VRAM to the iGPU. You can do that in BIOS. Like I said, they're my most popular videos on Tim's PC YouTube channel. So yeah, definitely check them out if you're interested. But yes, now's the time. If you've got any other final questions for me and stuff, now's your time to ask before I sign off for the night. Because I am keen for some food. I don't know about you. It's 8 o'clock at night for me, so I think that's about it. Alright, so look, thanks everyone for watching. Be sure to like and subscribe to the channel, and I'll catch you all in the next video.